Okay, today we're going to talk about complex formation and more specifically how to use Excel to do the repetitive calculations necessary to quantify this. As Dr. Daniel Harris's textbook, Quantitative Chemical Analysis, shows, if you have a metal and a ligand that reacts to form a solid substance, quite often, as you raise the concentration of the ligand, you start to form soluble complex ions. And so early on, you are controlled by the KSP and the common ion effect from your ligand, and later the concentration increases again because of complex formation. So this is a tedious business to calculate. Each of those points requires you to solve 1, 2, 3, 4, 5 different equilibria. So we're going to use Excel to do that using a somewhat simpler but still illustrates the principle, a zinc hydroxide. This is just a snapshot here. My actual graphic is blank. We'll fill that in as we do the calculations, which we'll do over here. So here are my reactions. The dissolution reaction, the KSP of zinc hydroxide to give us zinc ion and 2 hydroxyls. KSP value is there. We then have several complex ions that we're considering. The 1 hydroxyl giving us a ZnOH plus with what they call the cumulative formation constant beta 1 here, and so on. The 3 hydroxyls and 4. 2 just gives a straight line across, so I've left that out. This is also based on Dr. Harris's problem sets. Now what we're going to do is increment hydroxyl here, or rather log OH. So I'm going to start at -8, that's 10 to the -8, and increment by 0.2 log units. Oops, that should be -7.8. And we're going to drag that down. We're doing more than we actually need. We'll truncate this for the graphic. So let's do the antilog to get our hydroxyl concentration. So, whoops. (10) to the log. I'm not using negative log. I'm not using POH. I find it easier to interpret this way. So our zinc ion is controlled by KSP. So that's going to be equal to my KSP value, and I want to keep that there. What we'll do is make this an absolute cell address. I can do that by typing in $signs or hitting F4. To explain that a little bit, the $sign makes it not move in that direction. So $C means if I copy across, it doesn't move, and the $3 means if I copy down, it doesn't move. If I hit F4 again, now it will move across because the C is now a relative address, and the dollar in front of the 3 says when if I copy down it won't move. This switches it so that the columns are stuck still and the rows can move, and then we're back to relative cell addresses. But we always want it to be there at that point in our calculation. So rearranging our KSP, we're going to have square of hydroxyl concentration. So we can copy that down. And so now we'll work with beta 1. So our zinc ZnOH plus is going to be beta 1 times zinc ion times hydroxyl. So that's going to be equal to beta 1. We want an absolute cell address times zinc, which we just calculated using the KSP, times hydroxyl, which is 10 to the log. All right. Okay, now we'll use beta 3. That's so our zinc ZnOH3 minus 1 charge is going to be beta 3 times zinc times hydroxyl cubed. So we say equals beta 3, F4 makes it an absolute cell address, times zinc here, times hydroxyl to the third power. And copy that down. And now for the final one, ZnOH4 2 minus, that's going to be equal to beta 4 absolute address times zinc ion times hydroxyl to the fourth power. And now we will sum all those up to sum our total zinc concentration. Whoops, don't need the hydroxyl, just want the zinc containing complexes. All right. And now, since we're going through several decades of concentration, we'll take log. So we're going to do the base 10 log of zinc ion, and we can copy that over. We'll just copy everything there, and then we'll copy down, and we've got everything we need, I do believe. Let's go see. All right, now I've truncated this graphic because when you get down at the extremes, they're rather unrealistic concentrations. So I've truncated this to make it look better, but here's my KSP, my zinc ion. This one is that should be the single hydroxyl. There's the OH3, and there's the OH4, and here's the sum going down and then rising back up. Okay, that's all for this video. Thank you.